Hello, grade 10s, welcome. This is your host, Mr. T. It gives me joy to be presenting to you a lesson on transformation of graphs, focusing on reflections. In particular, we're looking at reflections in the y-axis. To help me do this, we're going to look at an example, a generalized example, I must say, where I'm going to give you a general function or an original function, which is given in the form of f in x. So the original function is f of x. Now, what we want to see is that looking at in function notation, what would be the reflected graph? How will it differ from the original function? So the only difference is that you're going to have f of negative x. If you notice the difference, the only thing that's different there is the negative in the reflected graph. That negative. Now, what you need to know as a general statement is that when you're reflecting any graph in the y-axis, it's as if you're multiplying wherever there is x by a negative. Or you're saying wherever there is an x, you're substituting by a negative x. So this can be generalized like that as a footnote. Multiply x by negative 1. Let's look at a specific example, and that will help us understand it clearly. So we're going to look at the first example where they say, given that f of x is equal to 2 to the power x minus 1 is reflected in the y-axis to give g of x. Question. Write down the equation of g of x. So we're going to start off by saying f of x is equal to 2 to the power x minus 1. Now, we know, and we've just said that in place of x, wherever you see x in the original function, we're going to sub in negative x. But this one is been named g of x, so we start by saying g of x is equals to 2 to the power negative x minus 1. Knowing your exponents well, you don't want to leave your answer with a negative exponent, so you're going to write it as g of x is equals to half to the power x minus 1 as your final answer. We move on to another example where you're given h in x is equals to negative 3 over x minus 2, and again it's reflected in the y-axis. Our solution is as follows. We're going to write h of x is equals to negative 3 over x minus 2 as our original function. Now we need to apply what we've just learned to say in place of x we're subbing in negative x. And that will give us h of negative x is equals to negative 3 over negative x minus 2. Very important. Now just to explain that further, or to remind us, I'll just say we are trying to substitute x in place of negative x in place of x. So we're substituting negative x in place of x. We then make a conclusion to say, therefore, h of negative x, which is the reflected one, is equals to 3 over x minus 2. And that's our equation of our reflected graph of h of x. We move on to the third and final question, where you're told to write down the asymptotes of h of x if h of x is a reflection of f of x is equals to 2 over x minus 3 about the y-axis. Again, we kickstart here by saying h of x is equals to f of negative x. Very important statement. H of x is equals to f of negative x. Why negative x? Because it's reflected in the what? In the y-axis. Then we do our substitution now to say, in place of f of x, the original f of x, we're going to substitute wherever there is x, we sub in by a negative x. And that's going to give us 2 over negative x minus 3. Therefore, our h of x is equals to minus 2 over x minus 3. Now, what are our asymptotes, one might ask? Our asymptotes, if you look at that equation, it's a case of identifying your q value and your p value, but we write them in terms of x. So our vertical asymptote would be x is equals to 0 and y is equals to negative 3 for the horizontal asymptote. I hope that's clear. Until next time, signing out is Mr. T. Bye-bye.